Hi everybody, welcome back to another video with Royalsoft Civil. In this video we are going to do a bit harder example on conjugate beam method. If you didn't watch my other example on conjugate beam method, I suggest you to go watch the easy example first, so because I talked about some of the concept you need to know in order to do this problem. So if you didn't watch that, go ahead and watch that. If you did, stay here and watch this problem. Okay, so and last example I mentioned that we did it and we didn't have an internal roller. So this example I want to show you a beam that has an internal roller and how we can draw the conjugate beam method for that. Okay, so the problem. Example 2. So find slope and displacement and displacement at C using conjugate method. Okay, let's go ahead and draw the beam. So this is our beam. We have a pin, we have a roller, and we have a load P. This problem I'm just going to use letters because sometimes your professor might choose a problem that is with letters instead of numbers. And basically it's the same, but you need to be familiar with it, so when you're doing in your test and this is your first time seeing something like this and you're not surprised. So I tried to show you. Okay, the first thing we need to do again is to find the reactions. So this is a pin, we only have okay, I forgot to draw this. So this is A, B, and C. So this is pin, so we only have AY, roller, BY, and at free end we don't have anything. So by doing some of the moments, this is basic static, I'm not going to do it, just going to say it. Doing the moment, some of the moment at A, we can find By, which is P over 2, and then some forces in Y, very easy, P over 2 for Ay. Now you need to draw the shear moment and bending moment. But if you already did this many times, you still need to show your work for shear so you don't miss anything. So for shear you can see it goes up, goes down, and like this. Goes up P over 2, goes down P, and back up P over 2 to 0. Right? So V, X. Now we draw our bending moment, M, X. Okay. And what is this? This is PA over 2. Now we have to draw the conjugate beam. Conjugate beam. Alright? So that's the part I said I talked about the concept in the previous video. So nothing happens to pin. We keep it as a pin. Pin. We have a internal roller. Internal roller becomes internal hinge. Hinge. And we have free end. becomes fixed, and none of the loading goes on conjugate beam, so only the bending moment goes there. So like this, and since this is positive, goes upward, and this is PA over 2 EI, and the distance from here is A, A, A. Okay. Since this is a hinge, we need to separate it and draw the free body for each side, right? I think you should know this. And so we draw one part like this and one like this. So right here we have so we have a AY prime right here. Why I draw it downward? Because I know this is going upward, so I draw it downward. And BY prime, we have a load one half PA over 2 EI times 2A, and BY prime, and what they want a slope and displacement at C. And what is the slope and displacement at C? The slope is the shear and displacement is moment, as I mentioned in the previous video. So V prime C and M prime C. So first thing we need to do is to find By. How can we find By? Very simple again. We do sum of the moment at A equals to 0. Remember, if I'm going too fast, you can always stop, do it, and then watch it again. So sum of the moment at A equals to 0 for this one. So 1 half PA over 2 EI times 2A times A minus By prime times 2A equals to 0. So this gives us that By prime is equal to PA squared over 4EI. Okay, now we have By prime. We can directly go to the other free body diagram, and we don't need to find By prime. Why? Because we're only dealing with the other free body diagram, which only has By prime in there. And we find the slope by finding the shear. And how can we find the shear force? By summing the moment in y direction. So sum of the force in y upward positive equals to 0. PA squared over 4EI minus V C prime equals to 0. So this gives us that theta C equals to V prime C equals to PA squared over 4EI. So this is the answer. And then the displacement of the moment at C counterclockwise positive equals to 0. So MC prime minus PA squared over 4EI times A equals to 0, and again this gives us delta C equals to MC prime equals to PA cubed over 4EI, and this is the answer. So you can see it's not that hard, only we don't use numbers. The calculation is a bit more, and if you have so basically this is the concept, and every other problem you have these three combinations and you need to do the same thing. The only thing you need to be careful is when there is a hinge, you separate it into different parts and calculate each free body diagram and move on. And pin stays pin, roller stays roller, except internal roller becomes internal hinge, and internal hinge becomes internal roller. Free becomes fixed, and fixed becomes free. That's the main concept for conjugate beam method. If you have any questions, feel free to comment below. Other than this, I hope you enjoyed this video, and thank you so much.